In this section, I will look at Domain Name System, or DNS. DNS is a system used to help users locate resources on the Internet. In this video, I will start with a bit of the background and history of DNS, followed by the new features that Windows Server 2008 DNS Server has to offer. Next, I will cover the components that make up a complete DNS solution. To better understand DNS and how it can work inside your network, I will cover the DNS Name Space. This will help you understand how you can start creating your own DNS namespaces and what rules you will need to follow. Next, you have the topic of DNS forwarding, which allows your DNS server to pass requests onto another DNS server to be resolved. Finally, I will cover installing DNS and configuring the server properties for DNS. Once you complete this section, you will learn that installing DNS server is the easy part. The hard part comes from understanding DNS and configuring it. DNS, or Domain Name System, is the most widely used name resolution system in place today. DNS was originally developed to be used on the Internet. When the Internet was first developed, computer names and IP addresses were stored in a file. This file contained all the computer names on the network and their IP addresses. When a change was made, the file had to be updated on all the computers on the network. When there were only a few computers on the network, this was not a problem. However, as more and more computers were added to the network, this became harder and harder. As more computers were added, the file also became larger and larger. The file became so large that it became impractical to keep copying it around the network, and thus DNS was born. DNS allows for a hierarchy model to be used rather than flat host files. DNS is easy to update as compared to having to update a host file on hundreds or even thousands of computers. Microsoft DNS Server meets Internet standards, so you can be assured that it will work with other DNS servers on the Internet. You will find that Microsoft's DNS Server is both powerful and easy to use. Over the years, the function of DNS has remained the same. DNS resolves names to IP addresses and allows computers to find services on the network. With Windows Server 2008, Microsoft has added some features to the DNS Server. One of the most noticeable features of DNS Server for Windows Server 2008 is support for IP version 6. If you have used DNS Server before, you will be familiar with the A record. An A record maps an IP version 4 address to a name. Later on in the course, I will cover DNS records in more detail, including A records. DNS Server for Windows Server 2008 has the ability to allow you to add Quad A records. Quad A records are the same as A records, except they hold IP version 6 addresses. If you are planning on deploying a DNS server in an IP version 6 network, Windows Server 2008 is fully IP version 6 compatible and ready to go. Later on in the course, I will cover zones in more detail. Zones simply hold DNS records and can be stored either in a file or inside Active Directory. Previously, with Windows Server 2003 DNS Server, if you stored your zone files in Active Directory and then rebooted the server, the data files or zone files would need to be loaded before the DNS server could start answering requests. If you had very large zone files, the server might not start answering requests for quite some time. If the client attempts to resolve a name that has not been loaded, the DNS server will not be able to resolve the request. In a large network, it is not unheard of for a DNS server to take up to an hour to load the zone files from Active Directory. As you can imagine, this is a long time to wait. To fix this problem, Windows Server 2008 added the feature Background Zone Loading. This works for zones that are stored inside Active Directory or Active Directory integrated zones. Under this feature, the DNS server launches a background process to load the zone data. This means the DNS server is ready to answer requests. If the client attempts to ask for a record that has not been loaded yet, the DNS server simply queries Active Directory to get the data, and Active Directory returns the data to the DNS. The data can then be passed on to the client. This means you no longer have to wait after a reboot of your DNS server to start answering requests. With Windows Server 2008, you can now deploy read-only domain controllers. As the name suggests, the Active Directory database on these domain controllers is read-only. If you store your zone data in Active Directory, when the DNS server tries to make a change on a read-only domain controller, it will not be able to. The request will then be passed to a writable domain controller, so don't worry if you install DNS Server on a read-only domain controller. As long as the read-only domain controller can contact a writable domain controller, you can still update your DNS data. Remember, this only applies to data stored in Active Directory. DNS Server gives you the option to store your DNS data in a file instead of Active Directory. If you store your data in a file, the DNS data can be updated on the server even if DNS Server is installed on a read-only domain controller. Don't worry if you are a little confused about zones. Zones will be covered in a lot more detail later in the course. Windows Server 2008 DNS Server also adds a new feature called Global Single Names. This allows you to use a single unique name over an enterprise network. With global single names, you can create one record in your forest, which is used in all domains in that forest. This saves you having to create one record in each domain for a global resource. To better understand the hierarchical nature of DNS, you need to better understand how the namespace is spread out. First of all, you have the root name servers. These resolve the first part of the domain name. The first part of any domain name working from right to left is dot. Just dot. Any fully qualified domain name ends with a dot. If you take the example www.example.com, the fully qualified domain name will end with a dot. This may seem a little strange to you, as you probably have never had to add the dot to the end of a domain name. This is because the DNS software will automatically append the dot to the end of the domain name for you. To start resolving any domain name, your DNS server will first contact a dot server, which are called root hint servers. There are 13 root hint servers on the Internet. These are independently managed. When you pay to register a domain name, you are paying to be part of this service. 13 may not seem a lot when you consider the size of the Internet, but this is in fact a limitation of the TCP protocol. Even so, the root hint servers are on high availability clusters, so you can be assured your DNS server will be able to contact one. The root hint server will return the IP address of a top-level domain DNS server. This DNS server contains details about the second part of the domain, for example, .com, .org, .net, and even country codes such as UK and AU. Your DNS server will then contact this server to get the IP address of a second-level domain server. This second-level server contains details of the next part of the domain name. The second-level domain can be registered to yourself and is the first part of the domain name you can host on your own DNS server. For example, the DNS records for Microsoft.com are stored on Microsoft's own DNS server and can be changed at any time by Microsoft, unlike the root and top-level domain over which you have no control. On the next level, you have subdomains over which you have complete control. You can even create subdomains of subdomains. On your DNS server, you are free to create any subdomain you wish without having to get permission and without having to register the domain name. All you need to do is make sure that the top-level domain points to your DNS server. As you can see, the DNS name system gives you a hierarchical base system of domain names and also allows the namespace to be spread out over many servers, providing expandability and redundancy. To better understand the name resolution process, consider this example. A client computer wants to resolve sales.example.com. It first contacts its local DNS server. The local DNS server sends a query to the root hint server. The root hint server responds back to the local DNS server with the IP address of a top-level domain server. The local DNS server contacts the top-level domain server. The top-level domain server responds back with the IP address of the second-level domain server. The local DNS server now contacts the second-level server. The second-level domain server also holds the subdomains. It is not uncommon for one DNS server to hold many different DNS namespaces. The server returns the IP address back for the DNS server for that domain name. The DNS server then returns the IP address back to the client. As you can see, a lot goes on to resolve a single IP address. But this system is necessary to allow the Internet to have the large domain space it has and provide redundancy and high availability to its users. In a lot of cases, it is not efficient to have each of your DNS servers contacting the Internet root servers. In a large network, this will result in more traffic than is required. Consider this example. Imagine there are 3 different networks. A client in each of the 3 networks attempts to resolve the same domain name. The DNS server in each network contacts the root hints server. The root hints server returns the address of a .com server to each of the DNS servers. The DNS servers then contact the .com server. The .com server returns the IP address of a server that is an authority for that domain. The 3 DNS servers then contact this server. This server is able to provide a response for the request. The request is returned to the DNS servers and passed on to the clients. In total, this took 9 different queries to resolve the 3 requests. This scenario is the default behavior for Windows Server 2008 DNS server. In a large network, this is not very efficient. If you configure forwarding, you can have one server on your network performing the DNS lookups for you. In a lot of companies, they will deploy this configuration. One DNS server behind a firewall contacts the Internet to resolve DNS requests for the others. If the same DNS name is resolved more than once, the DNS server will have the result in its cache. This makes DNS resolving a lot faster and reduces the number of times root hint servers need to be contacted. A lot of companies take it to the next step and configure their Internet DNS servers to forward requests to your Internet service provider's DNS server. In this scenario, all the company's DNS resolving requests go to the ISP's Internet DNS server. The ISP's DNS server contacts any required DNS servers to complete the request. As you can imagine, your ISP has many customers, and there is a good chance that they have already resolved the DNS name you are asking for, and it will be in the ISP's DNS cache. This will speed up your DNS resolving. All ISPs should have at least 2 DNS servers, so I would add both DNS servers to your list of forwarders. It is unlikely that both your ISP's DNS servers will go down, but if this were to occur, your DNS server would then default back to contacting the root hint servers. As you can see, using this scenario gives you fast name resolution and redundancy. In this scenario, all DNS resolve requests will go to your ISP DNS server to be resolved. In most cases, this is what you want. This can present a problem if you have DNS names that cannot be resolved by the Internet DNS server. When this occurs, you may want to use conditional forwarding. Consider this example. Client 1 wants to resolve example.local. The request goes to the ISP DNS server. .local domain names are private use only. Your ISP DNS server does not know how to resolve this DNS address. The DNS server at the bottom of the screen hosts the DNS records for example.local. You want all the requests for example.local to go to this DNS server. Conditional forwarding allows you to create a rule to forward requests for this DNS name to the DNS server that has the DNS records. These rules can be replicated to all DNS servers in your forest or your domain. This means you create the rule once and all your DNS servers will forward the request correctly without any more configuration. All you have to do is set the option to replicate the rules to all domain controllers. Once set, the rule will replicate to all domain controllers in your domain or your forest. Before you can add the DNS server role to your server, you first need to meet a couple of install requirements. First of all, your server must have a static IP address. The static IP address can be a version 4 or version 6 IP address. If you wish, you can assign a static IP address for both but as long as you have one static address for one of the network cards, your DNS server will work. To add the role, the user account needs to be a member of the local administrators group. When you install DNS Server on a domain controller, you can store the DNS data or zone data in the Active Directory database. Having the data in Active Directory allows you to take advantage of the Active Directory replication system, which is more efficient at replicating small changes and also provides you with redundancy. If you integrate your zone data in Active Directory, you can also enable secure updates. Secure updates is a feature that requires a computer to prove who it is before it will be allowed to change or add records to the DNS server. Without the secure updates feature, you either have to switch off all dynamic updates or allow unsecure updates. If you allow unsecure updates, it is possible for a hacker to compromise your DNS records. DNS is a very important service in Active Directory. Without Active Directory, it cannot function. Because of this, it is recommended that you have at least 2 DNS servers on your network for redundancy. If you have only one DNS server and it goes down, all your Active Directory-based resources will stop running. Let's have a look at how to install DNS Server on Windows Server 2008. To install DNS Server, open Server Manager from the Start menu. Select the option Roles from the left-hand side, and then select the option Add Roles from the right-hand side. From the list of roles, select the role DNS Server from the list. Press Install, and DNS Server will be installed to your Windows Server 2008 computer. As you can see, the install of the DNS role is very simple. Once DNS Server has been installed, you can expand down to DNS Server under Roles in the Server Manager. This screen will give you a quick indication of how your DNS server is running. As you can see, there are no events for the DNS server as yet, and if I scroll down a bit more, you can see that the DNS Server service is running. Down at the bottom of the screen, Microsoft gives you some links to access additional DNS resources. These links will help you further configure your DNS server and give you access to DNS best practices documentation. As you can see, installing DNS Server is easy. The difficult part is configuring it. In the exam, you may see the term Cache-Only DNS Server. In reality, all DNS servers cache resolved requests. This saves the DNS server from having to resolve the same name again each time it is requested. The difference between a cache-only DNS server and a regular DNS server is that a cache-only DNS server does not hold any DNS data or zones. The DNS server that I just installed is a cache-only DNS server and will continue to be one until DNS records are added to the DNS server. To understand why Microsoft makes the distinction between a cache-only DNS server and regular DNS server, consider this example. Imagine this network contains 500 users and is connected to the Internet. The DNS server contains DNS records for all the computers in the domain, plus any other resources and servers in the domain. This amounts to over 500 DNS records. Now consider that there is another office that has just opened with just 2 users connected to the main office via a slow network connection. The DNS server in the second office has a copy of the DNS records from the main office. Over 500 DNS records that change as computers come and go from the network are in the DNS server. In very large networks, you can see that the slow network link can easily become congested just simply trying to keep its local copy of the DNS records up to date. With only 2 users at the other office, there is little benefit to having a complete copy of the DNS data at the remote site. This is a perfect scenario to deploy a cache-only DNS server. In this case, you would not hold any DNS records on the remote DNS server and forward all DNS requests to the DNS server in the larger network. Cache-only DNS servers can still be configured to use forwards. They only stop being called cache-only DNS servers once you start storing DNS records on them. Once a request is resolved, it will stay in the local DNS server cache. The only DNS data that comes across the slow link is data that one of the 2 clients asks for. This makes better use of the bandwidth than copying over hundreds of DNS records that the two clients on the network are most likely never going to ask for. The advantages of cache-only DNS servers are that they are very easy to set up and require no administration. When I added the DNS role to the server in the previous example, the DNS server is automatically a cache-only DNS server and will start resolving DNS requests by contacting the root hint servers. Notice how easy it was to set up and no administration was required. In the exam, look out for questions where the best solution is to deploy a cache-only DNS server. Look for keywords like ease of administration, slow network links, or remote locations. Let's have a look at how to configure your DNS server once it's installed. Once you have DNS up and running, you may want to tweak your DNS server. To configure the properties of your DNS server, first open the DNS Admin tool from Administrative Tools under the Start menu. From here, right-click Your DNS Server and select the option Properties. On the Interface tab, you can select the IP addresses your DNS server will listen on. Notice that you can select IP version 4 or IP version 6 addresses here, or a combination of both. If your DNS server is only to be used on your local network, you should consider selecting the option Only the following IP address, and then select the IP address for your local network. Some hackers will attempt to read data from your DNS server to get an understanding of your local network. They can then use this information to hack into your network. It is not uncommon for companies to have an external and internal DNS server. If you do this, make sure that you set the Only the following IP address option so that the DNS server cannot accidentally be used to gather information by the wrong people. In this case, I will leave it on the default. On the Forwarders tab, you can enter in DNS servers onto which this DNS server will forward requests. Any request that this DNS server cannot resolve will be passed on to the DNS forwarder. A lot of companies will set up a DNS server on their DMZ to resolve all DNS requests. All the DNS servers in the company will direct their requests to this server. You can also put your ISP DNS server in here. On the Advanced tab, you have 6 tick boxes you can tick to change how the DNS server handles certain requests. The first is Disable Recursion, also disables forwarders. This means your DNS server will not attempt to contact other DNS servers to try and resolve names. If your DNS server is on a secure network or is only intended to service local clients, you may want to switch this option on. Hackers can send a lot of DNS requests to a DNS server that requires recursion to cause a denial of service attack. If your DNS server does not require recursion, switch this option on to make your server safer from a recursive denial of service attack. By default, Windows Server 2008 will use a fast transfer method to replicate data from one server to another. The option Bind Secondaries switches this option off and uses a slow transfer method. If you are communicating with a DNS server that is not compatible with Bind 4.9.4 or greater, then you need to switch this option. Bind 4.9.4 came out in 1996, so it is unlikely that any DNS server released in the last 10 years will not be compatible. If you do have an older system, you will need to switch this option on. The next option, Enable Round Robin, will return IP addresses in circular sequential order when more than one exists. For example, if you have 3 web servers, you could create 3 separate hosts records with the same name but with different IP addresses. When round robin is enabled, the DNS server will rotate through multiple records. If the next option, Enable Net Mask Ordering, is ticked, the DNS server will attempt to return an IP address in the same subnet as the client, if one exists. If round robin is also enabled, this may cause some unwanted results. For example, if I were to add a 4th server of the same name in a different subnet, round robin would work in the following way. Any clients in the same subnet as the server would get rotated between only the servers in that subnet. This means clients in the first subnet will receive only the first 3 servers when querying the DNS server. Clients in the second subnet will only receive the 1 server. If you wanted round robin to rotate through all records in the DNS server regardless of which subnet the client is located, you will need to switch Enable Net Mask Ordering to off. The last option, Secure Cache Against Pollution, helps protect your DNS server from having modified records placed in its cache. When the DNS server attempts to resolve a name, that DNS server will find a DNS server that is an authority for that domain. You can be assured that when this occurs, the IP address is correct. If you were to switch off Secure Cache Against Pollution, the following can occur. When your DNS server is trying to resolve a query, another DNS server could tell your DNS server the IP address of, say, Microsoft.com. This DNS server is not an authority for Microsoft.com, and thus the DNS could be used by a hacker to insert an incorrect IP address for Microsoft.com. When this occurs, the user can be redirected without their knowledge to another website instead of Microsoft.com. Having this option on does mean that you end up having to perform more queries to locate the authority server. However, the extra security is well worth it. The Root Hints tab is populated by default with the 13 root hint servers on the Internet. The default works fine, and you should not need to change this. In a very, very large company with a very complex DNS network, you may add your own root hint servers. However, this is very rare. On the Debug Logging tab, you can set a lot of logging options. As you can see, there is a lot of information you can log down to the packet level. If you're having problems with your DNS server, you may want to switch this option on. However, I would suggest using the Event Logging tab first. The Debug tab does record a lot of data and may have an effect on performance. On the Event Logging tab, you can log a lot of details in the event log. If you need to troubleshoot your DNS server, I would suggest trying this tab first over the Debugging tab. In most cases, the Event Viewer will log enough information to help troubleshoot your problems. The Trust Anchors tab is a new feature of Windows Server 2008 Release 2. When you set up Trust Anchors, the DNS server will contact a Trust Anchor to obtain a certificate. Using the certificate, the DNS server will return a digital signature with the DNS record. The digital signature allows the client to validate the DNS record as being correct. If security is a big concern on your network, you may want to consider using Trust Anchors to ensure your DNS records have not been tampered with or sent from a third party pretending to be your DNS server. The Monitoring tab allows you to perform 2 tests to make sure your DNS server is working. The first test is a simple query against the local server, while the second test will perform a recursive query using other DNS servers. If I tick both and press Test Now, you can see the test results below the button. This shows that both the simple and recursive queries are working. If you make changes to your DNS server configuration, for example, add forwarders, I would suggest performing this quick test to make sure that everything is working correctly. This concludes this section on configuring a DNS server. When installing DNS on your network, make sure that you have at least 2 DNS servers on your network. If one of the servers goes down, the other can still return requests from clients. Remember, Active Directory relies on DNS. Without DNS, your client will not be able to find your domain controller and will not be able to log on to the network. In some cases, you may want to deploy a cache-only DNS server. A cache-only server does not hold any records. Any requests that it receives are queried from another server. Look for questions in the exam that require a cache-only server. When deploying DNS on your network, remember, careful planning can save you a lot of headaches later on.